Hey guys, what's up? So today we are going to go through our practice problem of the day, smallest window containing all characters. So in this problem, what we are doing is we are given two strings S and P, and we need to find the smallest substring in S, which might contain all the characters that are, including duplicates, that are present in the string P, and if no such substring is found to us, which may contain all the characters that are there in the P inside the S, we need to return an empty string. And if there are multiple such cases where we can find all the characters, we need to return. Uh, we need if there are multiple such cases and they are of equal length, where we may find that a substring in S uh, has all the characters that are there in the P, we need to return the substring that starts at the minimum uh, at the minimum index. So yeah, for example, now here we are given an example. Time to practice, that's the S, and P is the TOC. We need to find TOC, a substring in S, which may contain all these three elements T, O, and C. So TOPRAC. This is like from index, uh, like from index 4 to index 9, I guess. Yeah. So this is a substring that is our answer. So this is basically the code that we have here. So what are we using here? We are using a sliding window and hashing for solving this problem. Uh, Now we will first initiate our answer string. We don't actually use it, but yeah, it is for uh, like yeah, it is a guardrail variable. Like if no such string is found, we will just return an empty string. Yeah, so now we will see if the size of S is less than that of the size of P. If that is the case, we will just return an empty string, because then there is no point of going through all this hassle, because if the size of S is lower than that of P, it obviously is not containing all the elements that are present in the P. Next, we have initiated a dictionary vector int frequency P, frequency S. So this 256 out here is actually the size of this dictionary. It is basically all the ASCII values that are there in the ASCII table, and this 0 is the frequency of those. The frequency of each 256 elements of the ASCII have been set to 0. Now after that we will initiate a for loop, which is going to iterate through the string P, and going to increase the frequency of each ASCII value in present in the FREQ P vector to 1 or 2 if it gets repeated. Now we will set the count variable to 2, minimum length to int max, and start to 0 and left to 0 as well. Left is going to be our pointer, that's going to initiate. That's going to be static, and right is going to be our pointer, that is going to be dynamic. So int right is equal to 0, and right is going to be obviously less than the length of the S, and we are going to increment it right plus plus, and frequency of S the characters that are present in the frequency S vector dictionary, we will going to iterate through the S string and increase their frequency by 1 each time that they are encountered. If the frequency of S right is not equal to 0, first of all, and frequency P S right, basically the element that we encountered in the string S, the element that we encountered in the string S, if its frequency in uh, vector freq P, freq P, is not equal to 0, and frequency S right, basically the element that we just encountered, is less than that of the is less than or equal to the frequency of it in vector p, we are going to increase the count by 1, uh, indicating that we have actually encountered an element that is present in the uh, p string. So once that is done, we are going to move on and going to see if the count is equal to p dot size, which is going to basically tell us that all the elements that are uh, there in the p string have been encountered, and we can move on further to now minimize the length of the substring, because obviously there could be a lot of because the left pointer is at an index 0, so there could be a possibility that we might have got the first element, the zeroth element, we might have gotten might match the element that is there in the uh, string p, but there is also a very highly likely chance that it is not the case. So we will obviously have to decrease the left pointer as there in the sliding window concept. Obviously we will have to decrease the left pointer to minimize the length of the substring so that we can get the most optimal value. So now while the frequency s vector s left, matlab the first element, its frequency is less than that of the uh, if its frequency is found to be less uh, in the less than that of its frequency in the frequency p vector, or frequency p vector is equal to 0. So what that basically means is that if that element is not present in the string p, or if that element's frequency in string p is less than that of its frequency in string s, then we are going to continue this loop. So what that means is like here we have time to practice. So what is going on out here? The frequency of t in this whole string is going to be like 3 time t, 2t, and practice maybe in practice also we have 1t. So frequency of t is going to be 3 in this case. So if its frequency is greater than that of the frequency that we have in p, so obviously it is greater, 3 is greater than that of 1. So we will proceed with this loop, and if the frequency and if the frequency of that element is greater than that of the frequency of that element in string p, we are obviously going to, we are basically double checking this condition. I'm sorry, we are double checking this condition here. If its frequency is actually greater than that of its frequency in p, we will decrease its frequency, and we will increase the value of the left pointer. So we will increase the value of the left pointer from t to I, 0 to 1, and similarly that is going to continue. Obviously it will be on a loop. It will keep on checking. It will first go to time, then to 2, then to it might actually go to, no, it is not going to go to TICE, because we have set a condition that okay, yeah, we have not set that condition. So yeah, it might actually go to TICE, but that won't be the case, because because there are other elements as well, and its frequency is going to decrease. The frequency of those elements is going to stop it from proceeding any further. Like we can't go lower than that of O, because the O's frequency out here is just 1 and simple. So yeah, now left plus plus, and yeah, we will obviously going to check that if the sliding window, if the value of if the size of the sliding window, which is right minus left plus 1, is less than that of the minimum length that we have set earlier, and if it if it is so, we will set the minimum length to the length of the current sliding window, and we will set the start value, which we set as 0, to left, basically the start of the window, the substring. And if, and at the end, if the length, or if the size of the minimum length variable is same as that we set in the beginning, we are going to return an empty string. Otherwise, we will just return a substring which is going to start from the variable index start, and is going to continue till the length of min length, which is in our case 6. Yeah, so it is going to continue up to the length of 6. So t 1 2 3 4 5 6. Yeah, so that is how it got out. And the time complexity that we received is 0.04, and it scored a good point. A brute force approach that you might that might come to your mind in the very beginning of it is like check all the substring, and once you check all the substring, pick the substrings that satisfy the condition of the elements of P being present in them, and then find the one which is of the minimum length. So that is not a very practical approach, and the problem that you will face in it is that it is going to give you a huge big time complexity of O of n square multiplied by into n, which is basically O of s square into O of p. So yeah, that's the time complexity that it will give you. And this right here is going to give you a time complexity close to that of O of 1. Close to, not exactly, but yeah. Okay, thank you very much.